All right, so before we move forward, there's something that I need to introduce to you that it's part of a bigger topic in Java programming, which is called polymorphism. Poly means many, a lot, multiple, and morph means multiple forms, okay? We will need to go back to the basics of classes and inheritance and all of that in order for us to understand that. And I do this because in order for us to move to what we are going to do next, which is to add an event listeners to our button, there are certain things that we need to talk about before we move forward. That way it's not too confusing, okay? All right, so let's go back to our animals project, okay? So if you remember correctly, I'm gonna go ahead and open our animals project there. Okay, I have it here. We created this animal class here. We've got properties. We have here constructor, we have setters and getters and so forth. That's wonderful. And we have certain behaviors as well. Eat and make noise. Now, let's open up our animal test, which has our main entry here, entry point. So we were able to create cat, right? A cat class, which inherits. So we actually have our cat class here, which extends or inherits from animal superclass. Okay, and we have this color here as one of its properties or instance variables. And we have a few setters and getters, and then we have this show cat method here. Okay, so we have all that. Now let's change the way of thinking here. If I were to tell you just animal, and I ask you what is an animal? Now, biologically, you could probably explain an animal is a living thing. But even when we define what an animal is, if you said just a living thing, right? A living thing that has probably other properties that would make it an animal. But even that, it's not very concrete, okay? Because an animal, if you look at an animal, philosophically speaking, an animal, it's an abstract idea of something that our minds represent or connect to something. Meaning, if I just say an animal, it's very easy to misunderstand, philosophically speaking, because you could say an animal could be a person, a human being, an animal could be a dog, right? An animal could be many other creatures that we know of. So an animal, it's a very abstract and very high level abstraction or something that it's more of a concept than an actual thing. However, if I say cat, then you have some sort of reference. You have something concrete, right? A cat, you will know, well, has whiskers and says meow and all of those things. Okay, now where am I going with this? Well, it turns out that if we were to go, let's go back here, an animal test here. So we were able to create a cat, we could create a lion. We did that when we talked about all of this, and many other animals that will extend or will inherit from the superclass animal. But what does this mean? If I said animal is equal to new animal, right? Because this makes sense. Cat is new cat. So we can actually start creating a cat and all of that stuff, right? That's fine. Lion, new lion, and we created an object of type lion here. But animal, but here when we try to instantiate an animal, so conceptually, what does that look like? Because if we say lion, instantiate a lion object, we at least have an idea. Well, a lion will have a name. We can have certain foods that it eats and number of legs. But an animal, it makes no sense, does it? Because an animal has a lot of different, it's just a concept. It's not necessarily a concrete thing. It's just a concept. But cat, lion, anything else below that is actually concrete. So this abstraction here, we have a way in Java in which we can actually represent this abstraction that is an animal, this idea, this concept that it's not concrete, right? Which makes our code cleaner and more extensible. In Java, we can create these classes called abstract. any classes that you want to create that are not concrete, classes that represent an idea, a concept, an abstraction, right? Such as animal or pet and many other abstractions that we can come up with, those need to be abstract, which means those classes, the abstract classes, contain one or more abstract methods. Now, an abstract method is a method that is declared but contains no implementation. Well, you may ask, okay, that makes no sense. So why would you go and create an abstract method, an abstract class, which you can't instantiate it? Well, because again, you can't instantiate something that does not exist. We are able to instantiate and make it work, a cat, because a cat exists. Why? Well, a cat is something concrete. You can't just touch an animal conceptually. An animal is just a concept, but a cat, yes, now I understand this is a cat. I can touch it, I can visualize it. An animal is too general, right? So what we can do then, we can then make this animal superclass an abstract class, which means all of its methods will be also abstract, which in turn means anything below our superclass, so cat, lion, hippopotamus, or any other animal that extends from our class here, animal class, will have to implement those methods declared in our animal. So all of this is just to prevent any other programmer from doing this, because this makes no sense conceptually, because we would not know what this animal object looks like. It's just a very strange blob of thing that has no concrete meaning, and that's not good, right? However, anything else below that, like a cat, which extends or inherits from animal, then has specific concrete identity. So this means animal needs to be abstract. So we're going to say here abstract. So if we go back to our animal test, you'll notice we have a problem. Well, because an abstract class cannot be instantiated like we do here, which is good. That's exactly what we're trying to avoid that happens. We cannot instantiate an abstract class. Why? Well, because it's not a concrete class. An identity, those are the ones that we want to always, those are the ones that we can work with, not just some idea of what something's supposed to be. Okay, so this is good. This is progress. Now, behind this abstraction here, the abstract classes, we will lead into what we call interfaces. Okay, so in Java, we don't allow multiple inheritance because that would be very disastrous. So what I mean by that is this. So cat cannot extend animal and extend something else class that we may have created. This is a big no-no in Java because it creates a lot of headaches and a lot of issues. That's why Java itself does not allow multiple inheritance. Now, that's a good thing. Now, there are times when we need to have common functionality to unrelated classes. For instance, an animal, right? For animals, we can have canine, we can have cats, we can have so many other animals as subclasses, as the children classes, right, of the parent class, which is animal, right? But there could be some other unrelated functionalities or unrelated classes that we can attach to it. For instance, a canine, besides of having all the properties of just of what an animal is, right? Sleep, eat, breathe, make noise, and all this stuff. Canine can also be a pet, right? So a canine can also be other things that are not necessarily too related to what an animal is. Now, this all may seem very strange now, but this is a very powerful paradigm used in Java, which allows us to create very flexible code. You notice here, going back, now our animal class is an abstract class, which means you can't instantiate it, which makes sense. Yet, we still have all of the methods that we had before here, okay? But one other thing we can do here, we can actually make also abstract methods here. If we go ahead and make this abstract as well, say here, abstract, okay, look what's going to happen. Well, if you click here, it's going to say something very cool. It's going to say remove abstract modifier as the first option. The second is remove method body, because every abstract method it's not supposed to have a body. Well, why is that? Well, it's because the whole idea here, if it's an abstract, we want to be able to implement that method in the child class. Meaning, if we do this, we're saying that, well, make noise, it's going to have to be implemented on the children class. So if we have, for instance, cat, when we instantiate cat, if we go here, instantiate cat, and we want to call cat that make noise, it has to be implemented here. So we had already overridden this, but we're going to get rid of this and save. And now inside of cat here, that's when you go ahead. If you click, says here, add unimplemented method. Because now what's happening here, we're saying, well, we are extending from animal, which is now an abstract class, right? So we can't instantiate it, but also it has this abstract method, which is make noise. It has no body. But since we are now creating a concrete class called cat, which extends the animal, we must implement the method because that's the contract. Okay, so that's the reason why we have this error here. So if we click here, it says add unimplemented method. If you click on that and say enter, and it will show here. It auto-generate everything. So this is where we go ahead and say system, and we can say cat. Okay. Notice it added here at override annotation here. Okay. This is all generated in Java. And this is the exact method we had here earlier. We actually forced this the overriding process here earlier when we were learning about classes. But now that we know about abstract classes and all this stuff, we were able to do that on the class level here, as you can see, on the main class level here, on the super class level, which is the animal. Okay, so now every class that will inherit from our animal will need to implement that. We'll have to implement our make noise here because this is an abstract method, which is inside of our abstract class. Okay, which means here in lion here, let's just get rid of this. If we save, we're going to have an error. There's see why? Well, because now we have to click here and we have to implement that. Okay, roar, save. And if you run, well, it's going to work just the same, as if nothing has changed. But we know a lot has changed because of what we just did here. You start thinking this way, you're starting to make your classes more manageable, more flexible, more efficient in so many ways, but also, most important, very robust. And of course, less code, because you notice now we only had to create this behavior here once, and it has to be implemented everywhere. As opposed to before, we actually had to write or make noise, but now we didn't have to. It's implemented automatically. Otherwise, the whole class would have an error. Bear with me here. I know this may be very confusing, but just bear with me. Just remember that we're trying to compact and make our classes more efficient, robust. All right, so I'll see you in the next video where we continue this discussion here before we jump back into talking about buttons.